Today we are going to use what's called the law of sines, and the law of sines is a theorem that we use when we have non-right triangles. So we're going to solve triangles today, and the triangles today that we're going to have are non-right triangles. So the first thing I'd like you to do is to copy down the law of sines, and the law of sines is simply if you have a triangle, and I drew an equilateral looking triangle here, but this is any triangle. Remember that the angle is a capital letter, so the side opposite the angle is a small letter. So this would be labeled small letters and capital letters. And really what the law of sines simply says is that the legs of a triangle and their angles are proportional. And we've talked about this before, and we've talked about it that if this were the largest angle, then this would have to be the largest side. If this were the smallest angle, then B would be the smallest side. But it's even more than that. So we have proportions, and those proportions are exact. So what you'll do, if you'll copy down these formulas, draw yourself a picture, and these formulas look about the same except for they're the exact reciprocal of each other. So write yourself a note, and what you'll always want to do when you use the law of sines is you want to put the unknown in the numerator, in the top of your fraction. So if we're finding an angle, we'll use this when we want to find an angle. And if we want to find a side, we'll use this law of sines. So really, they're not two different formulas, but that's how you'll use them. So copy down the law of sines, and then we'll look at a couple examples. So the first example that I'd like to use is a XYZ example, and notice that I've given you an angle and I've given you a couple sides. So we want to find the measurement of angle X. So remember what the law of sines says. The sine of an angle is proportional to its side. The side of another angle is proportional to its side. And if we're looking for an angle, we want to use the law of sines where the angle is in the numerator. So we want to find X. So we're going to set up the law of sines with the sine of X being in the numerator. So sine of X, this is what I want to find. Sine of X is proportional to its side. So I'd put a 6 because 6 is across from X. And then I want to set up the other proportion I have. So I know I have sine of Y, and I know that Y is 100. So I'll put 100 degrees here over leg Y, which is equal to a 10. Now you always want to set up the law of sines so that you have what we call three knowns. We know three things, and we only have one unknown. And why do we want to do that? Because when we want to solve for the missing, we can just cross multiply. So we get sine of X equal to 6 times the sine of 100, all divided by 10. So the sine of X, when I punch, I'm going to get the sine of X is equal to 0.5908. But remember from a previous lesson, now we have to take the sine inverse of that because I'm finding an angle. So when I take the sine inverse of that, I'll get 36.2 degrees. And that's what X is. So let's see if that makes any sense. If X is equal to a 36.2, that should make some sense to us because 100 is across from the 10, and this leg is only 6, and it should be a little bit smaller. Let's look at a second example. Again, I have a XYZ. So I want to solve for angle X. So again, put the sine of X in the numerator. X is across the 17. I have sine of 115.2 all over 33. We'll cross multiply. So again, the sine of X is going to equal 17 times the sine of 115.2. Again, make sure you close your parentheses on your calculator before you divide by 33. Then you'll take the sine inverse of that answer to get what X is. So punch with me. So 17 times the sine of sine inverse is going to equal 0.466. When we take the sine inverse of that, the angle should be a 27.8 degrees. So the law of sines is just a ratio. When we're trying to find ratios, we just set that law of sines up. In example 3, I've asked for a side instead of an angle. Okay, so again, we're still going to use the law of sines, but this time I asked for EF. So EF is this line segment. Let's use letters to denote what this side would be small d. Why? Because it's across from angle D. So earlier I said you want to set up the law of sines such that the unknown, what we want to find, is in the numerator. And then you always want to put the ratio of what I know. So if I have E, I know, over the sine of E, and F over the sine of F. So you want to choose the law of sines so that you have 3 knowns and 1 unknown. So we know this is our unknown. Let's see if we know angle D. We know angle D is 72, so we know that. F we know is 43, so we know that. But this time we don't know angle or side F, so that's an unknown. E we know is 13, but we don't know anything about angle E either. So the way this looks is it looks like we have 1 unknown, 2 unknowns, 3 unknowns, and 3 knowns. So you want to set this up so that we have 3 knowns and only 1 unknown. So we've got to go back to doing a little geometry. And what do I mean by that? We know that D is equal to 72. We know side E is a 13, but we don't know angle E. Oh, but we really do, because we know all triangles have 180 degrees. So if I add the 72 and the 43.8, I'll get 115.8. And then if I subtract that from 180, I really know that E is equal to 64.2. So this is a little tricky. You've got to find that angle sometimes. And again, how do you know if you need to find that? You know to find that if you're given 3 unknowns and 3 knowns. So somehow you want to set up your law of sines so that you have 3 things that you know and only 1 thing that you don't know. Now, again, now we want to cross multiply, solve for D. This time solving for D is a little bit easier because all you got to do is cross multiply. Again, make sure that you close your sine of 72. And we don't have to do anything extra because this is what D equals. And that's it for your law of sines. I'm going to do one more example with you with a DEF triangle. We want to find a side. This time we want to find DF. So I would label this E. And let's again see if we can set up the law of sines so that we have enough information. So E is proportional to angle E. And we're given 107, but we don't, or 106, but we don't know anything about this leg. We do know something about the 33 leg. So this is across from what angle? 33 is across from this angle here. So I don't have that angle, so that's how I know I'm going to have to go find it. So 106 plus 27.5, subtract off 180, that gives us 46.5. When we have this much information, we have what I'm calling three things that we know and only one thing that we don't know. We can cross multiply, and so E will equal what? 33 times the sine of 27, 27.2, 27.5. Make sure you end that divided by the sine of 46.5. One of the most common mistakes is students don't close that parentheses, so they get incorrect answers. Make sure you punch with me. Let's see if this makes any sense. Should E be pretty? We're looking for side E as a 21, and that should be pretty small. Why? Because it's across from the smallest angle. So again, check your answers. Make sure you copy down your notes very well. I'd like you to do worksheet 13.4. I'll post the keys so you can check to make sure you're doing it right. But again, you have to show all your work. And what's your work? You have to set up the law of sines. Once you set up the law of sines, then you can go to your calculator and just get the answer. So this is the step I'm looking for on your worksheet. And then you can go to your calculator and then write final answer.